Hello, everyone. Welcome to our talk. My name is Benjamin Elder, and this is Amit Wapwe. We'll be speaking on Kubernetes testing with Kind and Kubetest2, two tools from the Kubernetes testing special interest group. What is Kind? Kind is Kubernetes and Docker. It uses Docker containers to simulate Kubernetes nodes. So instead of a virtual machine or a physical machine, we use Docker containers. And this allows us to run pretty much anywhere that you can run Docker, be it in various CIs, locally on your workstation, wherever. It can run multi-node clusters by running multiple containers and wiring them together. It can run IPv4, IPv6, or dual stack clusters, which is a little unusual. It can build and run Kubernetes from source, which is very important to us in the Kubernetes project for developing Kubernetes itself and where this project originates from. And on a machine with everything pulled, warm, hot, ready, it can boot a cluster in 30 seconds or less, which is pretty awesome for development. So why Kind? Well, for testing Kubernetes, that's why we built it. For testing applications and controllers, which we figure probably what most of you are interested in. And for bootstrapping cluster API clusters, where the clusters themselves depend on tooling that runs in Kubernetes to create clusters. And it's turtles all the way down. So Kind makes a great bottom turtle because it's very simple, lightweight, and easy. You can run a Kind cluster, install your cluster API controllers, and create a cluster API cluster. This is something else we support. So how does it work? Well, as I said, we create node containers. So you can see here you have Docker running on your workstation and the Kind command line, which is talking to Docker. The Kind command line will talk to Docker and tell it to create node containers. These node containers are going to run a number of little tricks and get systemd, kubelet, containerd, all of the Kubernetes components from CoreDNS, kubeproxy, etcd, kube controller manager, kube scheduler, kube API server, and anything else that may become a future system component running. This uses kubeatom, which is a fairly standard tool within the Kubernetes project for doing machine bootstrapping. And then it will also run your user containers nested here, and kindnetd, a small networking daemon we implemented for very lightweight implementation of Kubernetes networking and CNI. So it keeps everything very nice and lightweight. It's pretty straightforward. It's like Docker and Docker, if you're familiar with that. It has some additional things going on, but it's pretty much the same concept with nested containers. So I said Kubernetes and Docker, but we also have Kubernetes and Podman. I'm going to call it that. We like the Kind acronym, a little easier, but we have Podman support now. You can use Podman instead of Docker, which is pretty nice for users in the Red Hat ecosystem in particular. It also supports rootless now, Podman or Docker. Shout out to Akira Suda for working on this in the upstream community in Kubernetes and Podman and Docker and Kind in particular. This is some pretty cool work that has landed recently to enable this throughout the entire ecosystem. So if you have rootless installs, everything should just work now. And in the future, we may consider supporting additional runtimes as we see demand. But for the moment, Kubernetes or Podman. So not just Docker. Installing Kind is also pretty simple. You can go get it if you're familiar with that as a Go developer. You can brew install it if you're on using Homebrew on Mac or Linux. You can use Mac ports or Choco if you're on Windows. We also have release binaries on GitHub, and our docs have more information about how to install from the release binaries or any of these options. You'll also want to install kubectl, which we will point you to the upstream docs for the Kubernetes command line for interacting with your cluster. So to create a Kind cluster, you call kind create cluster. That will get you a single node cluster with the default settings. It will be named Kind, and it won't have any fancy options. It's a single node, and it will default to a recent Kubernetes version. You can add a name, and instead of naming it Kind, you can call it something else. Here we're calling it cluster 2. Doing this allows you to create as many clusters as your machine can handle before you start running out of resources. It varies quite a bit depending on workloads and things. So we don't have any hard rules for this, but if you give them different names, you can create as many as you want, and then just use that name flag with the other commands to let it know that you're not using the default cluster. I find most of our users just use the default cluster, but once you start to get more advanced, you might want to do multi-cluster testing or have different clusters for different things you're doing. So pretty handy option. For more advanced usage, we support Kubernetes style component config. So we have configuration docs here, but basically it's like Kubernetes component config. You need to set an API version and a kind. The kind is cluster. The API version is an experimental one, depends on the kind version. And you can use this to set all sorts of things about your cluster. So some examples, you can enable Kubernetes feature gates across all the components. So in this case, we're enabling the CSI migration feature gate. So you can test that, install your CSI drivers, make sure that it works. It's only a few that are going to work on kind, but there's many more feature gates like this that you could enable or disable, including default feature gates. And on a related note, you can disable or enable in the runtime config the APIs at this level. So a pretty common thing that you might want to do is disable, say, beta APIs and make sure that your cluster is not using that. You might also want to do alpha. So you could disable alpha beta APIs, make sure that your tests are only using GA features that are going to be available everywhere. Maybe you're using K3S in some places or something, so you don't want to depend on any alpha or beta features. We use this in Kubernetes upstream. We do conformance tests and make sure that they're not depending on non-GA features, so it's easier for providers to meet this. So it's a really cheap and easy way to toggle features and functionality in your cluster. We hope this is very easy to use. And there's more docs on this on the site. So when you're doing this, when you're testing with kind, typical flow is pretty straightforward. It looks like this. So you're going to create your cluster with kind create cluster. Then you're going to build your application, your images, your Docker images, whatever your app needs. Once you're done, the most common thing people do is use kind load Docker image. So that's going to take your image from Docker. It's going to export it as an archive. And then it's going to side load it into all the nodes, containerd, container runtimes, and make sure that that image is available for them to run with without need for the internet. So it keeps everything nice, hermetic, and local, self-contained, easy to work with, no external dependencies, no problems if your registry goes down. Alternatively, you can push to a local or a remote registry, and that will work fine as well. We have some more docs about how you can integrate a local registry. But most people are going to use the loading. Loading has some other nice properties, like you don't need to rename your images to go to the special testing registry or something like that. You can use your production image tags because it's never going to be pushed, just load directly. Then you run your usual end-to-end application tests, whatever those may be. So in the Kubernetes project, those will be Ginkgo tests. And then after you've run your tests, we have a handy little command, kind export logs. They'll allow you to get all of the system logs from all the nodes and all the details about the cluster that you can use to debug that sort of thing, or bring to us and tell us, hey, we found some problem with kind. Here's the system logs. These are pretty handy to capture. Highly recommend this. After you've captured the logs, you can delete the cluster. For all of these commands, if you've used a different name, you just add the name flag. So kind load Docker image, kind export logs, kind delete cluster. Just pass the name of your cluster. You can also do this with an environment variable. We have more details on this on the site. So you might recognize this flow as being pretty familiar, and a little bit here when Amit talks to you about Kubetest2, another tool that we use for testing Kubernetes that you may also find useful for testing your own applications.
Thanks, Ben. Hi, everyone. I'm Amit, and I'm going to go over another tool that we use in the Kubernetes project called Kubetest2. So, Kubetest2 is a framework for launching and running end-to-end tests on Kubernetes, and it is intended to be the next significant iteration of Kubetest. Kubetest V1 is the framework that we use currently in the Kubernetes project for continuous integration testing, or CI, and runs about thousands of jobs daily. It comprises of a single binary encompassing all the different combinations of environments and scenarios that we test in Kubernetes in CI. It evolved organically from a bunch of legacy scripts, and in some cases, literally from shell scripts, to the point where it's starting to become a bit unmaintainable. Which is why one of the primary goals of why we created the Kubetest2 framework is to move away from legacy dependencies and to build something that is more easy and extensible. So, what are the primary features that Kubetest2 provides? The number one feature that Kubetest2 provides is consistent cluster lifecycle. A typical testing flow for Kubernetes looks like building some binaries from your change, deploying the cluster, running some tests against the cluster, and then tearing it down. In Kubetest2, we have standardized and codified this lifecycle to make it easier to enable different testing workflows that you might have. We will go into some more detail in the upcoming slides. The next thing that Kubetest2 provides us is decoupled deploy implementations. So Kubernetes comes in multiple flavors and offerings, be it distros, installers, providers, and in many cases you want to run tests against at least a few of these deployers. So Kubetest2 provides a way to not only run your tests against these different deployers, but also allows you to extend the framework to include your own implementation of Kubernetes. Alongside deployers, we also provide support for plug and play testers. So plug and play testers allow you to run different kinds of tests in a very user friendly way, in a plug and play fashion, where you can be it your own application or any other test that you're planning to run against the Kubernetes cluster. The one of the key features that we wanted as part of the Kubernetes developer lifecycle itself was being able to run CI testing jobs locally with as much hermetic reproducibility as possible. And as part of our goal to minimize legacy dependencies, we provide a unified command line interface to be able to reproduce the system under test in both CI and local environments as closely as possible. Lastly, Kubetest2 also integrates seamlessly with other tools that we use as part of the Kubernetes project, one of them being Boscos. Without going into too much detail, Boscos is a tool that we use in Kubernetes CI for leasing testing related environment dependencies or resources at runtime. Most canonical example being renting a clean Google Cloud Platform project for the duration of the test to run tests against the GCE cluster. Now let's take a quick look at the architectural overview of Kubetest2. As mentioned earlier, a typical flow is broken down into multiple phases. We start with the build phase, which is mostly an optional phase and which we most preferably use in the developer lifecycle upstream. And in this phase, we build Kubernetes artifacts from source, be it the actual Kubernetes binaries or the integrated upstream end-to-end test binary, or other tools like the kubectl CLI itself, which you would want to use to interact with your cluster. Then comes the up phase where we actually deploy a cluster. In addition to being able to deploy your own flavor of Kubernetes, we also support a bunch of standard Kubernetes providers that we use in upstream testing, be it GKE, GCE, kind that we all heard Ben just talk about, or Kubernetes operations or COPS clusters in short. Then we have the actual test that we want to run or the test phase. Canonically, we use the Ginkgo framework upstream for running the end-to-end test binary itself. In addition to that, we also have a few frameworks specifically for testing Kubernetes node and scalability of the cluster. Or apart from these canonical test frameworks, you can also test with your own application or controller, or it can even be a simple shell script that you want to exec against the cluster. And lastly, we have the down phase where we tear down the cluster, cleaning up the testing environment, also releasing any testing resources that we might have rented from Boscos. Now let's take a quick look at the actual command line and how it looks like. So Kubetest2 uses the binary plugin mechanism for detecting plugin deployers and testers. The binary plugin mechanism is used widely across the project, including kubectl itself. The way it works is that binaries are named in particular standardized format. In this case, kubetest2 dash your deployer would be used for your deployer binary, and kubetest2 dash tester dash your tester name would be used for a kubetest2 tester. And the actual command line invocation looks something similar to what kubetest2 deployer, your deployer name, dash dash build, dash dash up, dash dash down, specifying the phases of the test that we want to run, followed by any additional deployer args that you want. In addition, you will also specify dash dash test, the tester that you want to include, and then followed by any of the tester arguments that you want to provide. And here we have a quick example of how we run upstream CNCF Kubernetes conformance tests against a GKE cluster. So thank you everyone for listening to our talk. Both Kind and Kubetest2 are part of the Kubernetes project and are sub-projects of the testing-oriented special interest group, or SIG testing as we call it. You can find links to both the projects as well as our community page as shown here. And we are always welcoming anyone wishing to join the community. So please feel free to join us. Thank you.